Hello everyone, good morning. This is lecture number 26 of ODE. So if you haven't watched all the previous videos, so please watch all the videos before watching this video, right? Super. So in this class, we're going to start a new topic called orthogonal trajectories, right? Orthogonal trajectories. In the next class, we will be completing ODE, right? So this is part 1 of orthogonal trajectory. The next class, we will see part 2 and then we will wind off orthogonal trajectories, right? We will wind off orthogonal trajectories in the next class. So therefore, ODE syllabus will be completed in the next class, right? Super. So first in this class, what we will do is we will define what is meant by orthogonal trajectories and then we will tell the procedure of how to find the orthogonal trajectories for the given family of curves, right? Super. So first what we will do is we will define what is meant by orthogonal trajectories, right? Super. So we'll start. Okay. So first we will define what is meant by trajectories, right? So first we will define what is meant by trajectories and then we will define what is meant by orthogonal trajectories, right? Super. So what is trajectory? A curve which cuts every member of a given family of curve is called trajectory. Very simple, right? If a curve cuts every member of a given family of curve, then that curve is called trajectories, right? I have given you an example. So consider the family of curve x square plus y square is equal to a square. This is a family of curve, right? See, this is the equation of circle. This is the equation of circle with the center 0, comma 0 and radius a. Here a is a parameter. That means if I keep changing a, we will have different circles, right? For example, if a is equal to 1, we will have a circle of radius 1. If a is equal to 4, that is if a is equal to 2, then this will be 4. So we will have circle of radius 2 with the center 0, comma 0. If a is equal to 3, if I keep on changing a, we will have a family of circles, right? Here a is a parameter. That means if I keeps on changing a, we will have a set of family of circles. If, for example, if a is equal to 1, we will have a circle of radius 1 with center 0, comma 0. If a is 2, we will have a circle with the center 0, comma 0 and radius 2. If a is 3, we will have a circle with the center 0, comma 0 and a radius 3, right? So therefore, we will have this is a family of circles. Now for this will go on and on, right? For example, I have drawn only 3 circles. If a is equal to 4, we will have another circle. If a is equal to 5, we will have another circle. See, for this family of circle, you can see this y is equal to x line. This y is equal to x line cuts cuts every member of a given family of curve. So for this family of circle, you can see the line y is equal to x. This is a line y is equal to x, right? So this cuts every member of this family of circles. So therefore, this y is equal to x is called trajectory for x square plus y square is equal to a square. Very simple. We have a family of curves. If a curve that cuts every member in this family of curves, then this curve is called trajectory, right? Very simple, right? Okay. Now we will define what is meant by orthogonal trajectory, right? So what is trajectory? So we will have a family of curves. If there is a curve that cuts every member of the family of curves, then this curve is called trajectory. Super. Now we will define what is meant by orthogonal trajectory. Very simple. If this curve cuts the family of the curves at right angles, then this curve will be called orthogonal trajectory. So trajectory means it has to cut, that's it. Suppose if it cuts at right angle to the every member of this family, then this curve is called orthogonal trajectory, right? So you know how to find angle between the two curves, right? So angle between the two curves is nothing but angle between the tangents drawn at that point. For example, let us find the angle between this curve. See, line is also a curve in mathematics, right? So for example, let us consider this circle, right? The first circle. Let us try to find the angle between this line and this circle, right? So angle between the line and the circle is nothing but you just draw the tangent line for 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 this circle and this line, right? For example, what will be the tangent line? What will be the tangent line? for this curve at this point. This is a tangent line, right? Right? This is a tangent line. Now you have to draw the tangent line for y is equal to x at this point, right? Y is equal to x at this point, right? So that angle, the angle between the two tangents is called the angle between the two curves at that point, right? Very elementary. Suppose if that angle, right, you have to draw the tangent line at this point for y is equal to x, and the angle between the two tangent line is called the angle between the two curves, right? So very simple. So if this curve cuts every member of this family right angles, then this curve is called orthogonal trajectory, right? So if a curve cuts every member of a given family of curves and right angles, then it is called orthogonal trajectories. You can easily see, right? I give you an example, right? We know that. Okay, I think don't I don't want to discuss more. So very simple. So what is trajectory? So in the question they will ask you to find the orthogonal trajectory, right? In the question they will ask you see, line is also a curve in max, right? Okay. In the exam point of view, what they will give is they will give a family of curves, and you have to find the orthogonal trajectory. That means what? For that family of curves, you have to find a curve that cuts every member in the family, as well as that curve has to cut at right angles to the every member. Very simple. So in exam point of view, they will give a family of curves, right? They will give a family of curves. You have to find the orthogonal trajectory. That means you need to find one curve. That curve has to cut every member in the family of curves, as well as that curve has to cut at right angles also. Very simple, right? Okay. Now you need to how to find the orthogonal trajectory. Very simple. So there are three methods. Sorry, there are three steps to find the orthogonal trajectory. So first step is differentiate the given equation of family of curves and eliminate the parameter. Very simple, right? So first you have to differentiate the given equation of family of curves, and then you have to eliminate the parameter. So here A is parameter for this example. So I'll demonstrate with the example. Very easy. So first is you have to differentiate the given equation of family of curves and eliminate the parameter. Replace dy by dx by minus dx by dy. After that, you have to replace dy by dx by minus dx by dy. So after that, you will get a differential equation, right? After step 2, you will get a differential equation. Solve the differential equation to get the orthogonal trajectory. Very simple. I'll give you an example. Very, very easy problems, right? So in exam point of view, they will give a family of curve. You have to find the orthogonal trajectory. That means what? You have to find a curve that cuts every member in the family, as well as it has to cut at right angles. That's it. Okay. So we'll move on to problems. So in this class, I'm going to do 7 problems, right? I'm going to do 7 problems based on orthogonal trajectory. So you can see find the orthogonal trajectory of y is equal to ax square, where a is a parameter. We have a family of curves, right? So we have a family of curves. For example, so what is y is equal? If a is equal to 1, we will have y is equal to x square, right? If I vary a, we will have a different set of curves, right? So if I vary a, we will have a different set of curves. This is a family of curves, right? Here a is a parameter. If a is 1, if a is 2, if a is 3, if a is minus 1, if a is minus 2, we will have different set of curves, right? Now we need to find a curve that cuts every member, then last it has to cut at right angles also, right? If a is minus 1, we will have y is equal to minus x square, right? So if a is negative, we will have this. If a is negative, we will have this group of curves, right? Super. So we need to find a orthogonal trajectory for this family of curves y is equal to ax square. Okay. So what is the first step? What is the first step? Very simple. So differentiate the given equation of family of curves and eliminate the parameter, right? That is we have y is equal to ax square, right? So very, very important topic. So call this as equation 1. So you need to differentiate this with respect to x. So we have dy by dx is equal to a into x square is 2x. So we have dy by dx is equal to 2ax. So we have differentiated the given equation of family of curves with respect to x, right? With respect to x and eliminate the parameter. So we need to eliminate this a, right? We need to eliminate the parameter a. So how to eliminate a? Very simple. So from 1 you find the value of a. A is y by x square, right? So replace that. So we have dy by dx is equal to 2 into, so instead of a I'm going to write this as y by x square into x square, right? So you can see from 1 a is y by x square, right? So from 1, right? So from 1 a is y by x square. So we have completed the first step, right? Differentiate the given equation of family of curves with respect to x and eliminate the parameter. So we are done with this, right? Super. Now we have to replace dy by dx by minus dx by dy. So replace dy by dx by minus dx by dy. So this will be minus dx by dy is equal to 2 into, sorry, this is 2ax. So d 2ax, so a is y by x square. This is same as 2y by x, right? That's it. You need to solve this differential equation to get the orthogonal trajectory, right? So you can see we are done with step 2. So first step is differentiate with respect to x, eliminate the parameter, replace dy by dx by minus dx by dy, solve the differential equation to get the orthogonal trajectory. We need to solve this equation. That's it. So we will have minus x dx is equal to 2y dy. Now integrate this. So integrate this. So we will have minus x square by 2, 2 into y square by 2. Let us take a constant to be equal to c1, right? So these two will get cancelled. So we will have minus x square by 2 minus y square is equal to c1, or this is same as if I multiply by minus throughout, and if I so this is same as x square by 2 plus y square is equal to some constant c2, right? I'm just multiplying throughout by minus, and I'm just minus c1. So minus c1 I'm taking as c2. Now you can see what is this? This is an ellipse, right? So if I divide by c2, if I divide by c2, we will have x square by 2c2 plus y square by c2 is equal to 1, right? So you can see this orthogonal tangent is an ellipse. This is an ellipse, right? So this is a curve that cuts every member of the family, and also it cuts at right angles also, right? Very simple. This is the orthogonal trajectory. This is the orthogonal trajectory, right? So very simple. So what you have to do is differentiate the given equation of family of curves and eliminate the parameter. So we have differentiated this with respect to x. Eliminate the parameter. So we have found the value of a from 1 and we have replaced that. Now we have to replace dy by dx by minus dx by dy, and then you have to solve the differential equation to get the orthogonal trajectory. Is it clear? Is it clear, right? Very simple. Okay. So we'll move on to the next problem. Find the orthogonal trajectory. Find the orthogonal trajectory of x square plus y square is equal to 2ax, where a is a parameter, right? Where a is a parameter. So if I replace a to be 1, 2, 3, 4, minus 1, minus 2, 1.5, 2.5, you will have a family of curves. You need to find one curve that intersects, that cuts every member at right angles, right? So very simple. So solution. So let us take the given equation and call that as equation number 1. So we will have x square plus y square is equal to 2ax, right? Now differentiate with respect to x, and we need to eliminate the parameter, right? Differentiate with respect to x. So we will have 2x 2y dy by dx is equal to 2a, right? Differentiate with respect to x. Now we need to eliminate the parameter, right? So we need to eliminate this parameter. So from here I can find the value of 2a, right? From there I can find the value of 2a. So what is 2a? So 2a is 2x plus 2y dy by dx. So instead of 2a I can write x square plus y square by x. This is from 1, right? 2a is x. So we can see we have differentiated with respect to x, and then we also eliminated the parameter. We have eliminated the parameter, right? We have done with that. So first step is over. We have to replace dy by dx by minus dx by dy. Before that, we will simplify this to some further extent. So we will have 2y dy by dx is equal to x square plus y square by x minus 2x, right? I'm taking this term that side. This is x square plus y square minus 2x square divided by x. So we will have dy by dx is equal to y square minus x square, right? X square minus x square. So it will be y square minus x square divided by 2xy, right? Divided by 2xy. So I have just multiplied this 2y here. Now what is this? Now we have to replace dy by dx, right? So this is step 2. So replace dy by dx by minus dx by dy. So we will have minus dx by dy is equal to y square minus x square by 2xy, right? Now let us take this minus outside common here. So this minus will get cancelled, and also if I reciprocate, we will have dy by dx is same as 2xy divided by x square plus y square, right? I have just taken minus outside here, so it will be x square. If I take minus outside, we will have x square minus y square, right? Sorry, we will have x square minus y square, right? So I have taken minus common in the I have taken minus common in the numerator, so we will have x square minus y square. Minus minus will get cancelled. We have reciprocated, so that we will have dy by dx to be equal to xy by x square minus y square. So we need to solve this equation to get the orthogonal trajectory. Now what is this equation? This is a homogeneous differential equations, right? So numerator and denominator both are homogeneous of degree 2, right? So f of tx comma ty is equal to t square f of x comma y. So both are homogeneous. So both are homogeneous of degree 2, right? So f of tx comma ty is equal to t square f of x comma y. So this is a homogeneous differential equation. So how you solve? Put y is equal to vx. You know how to solve this equation, right? Very simple. The solution of this differential equation is the orthogonal trajectory. So put y is equal to vx. So therefore your dy by dx will be v plus x into dv by dx, right? Product rule. So you can replace this, right? So dy by dx is v plus x into dv by dx, and you have to replace this 2x y by vx divided by x square minus b square x square, right? So this x square x square. So if I take this common, it will get cancel. So we will have b plus x into dv by dx is equal to 2v divided by 1 minus b square. So we need to solve this equation. So we will have x into dv by dx is equal to 2v divided by 1 minus b square minus b, right? So we have x into dv by dx is equal to 2b minus b plus b cube. 2b minus b plus b cube. 2b minus b plus b cube divided by 1 minus b square, right? So 2b minus b plus b cube divided by 1 minus b square. Is it correct? 1 minus b square, right? Okay. Now 1 minus b. Now this is x into dv by dx equal to, so 2b minus b is b. So b plus b cube divided by 1 minus b square. So if I cross multiply this, we will have x dv 1 minus b square is equal to b plus b cube into dx, right? So 1 minus b square divided by b plus b cube dv is equal to, these are very simple, right? We have already solved many problems based on homogeneous differential equation, and these are very simple. Now you need to integrate this, right? So integrate this to get the required solution. Now here you need to do partial fraction. You need to do partial fraction here. So this can be written as a by b plus bb plus c divided by 1 plus b square, right? This comes under case 3 of partial fraction where this has no real roots, right? db, and this is log x plus log some constant log c1, right? Plus a constant log c1. Okay. Now you just have to find the value of a, b, c, right? You know how to. I'm just doing partial fraction. That's it, right? Very simple. That is what I'm doing here is I'm just doing the partial fraction for 1 minus v square divided by b into 1 plus v square. So this will be a by b plus bv plus c divided by 1 plus b square. Now multiply throughout by b into 1 plus b square. So 1 plus b square is equal to a into 1 plus b square bv plus c into b square. Now find the value of ABC, right? Find the value of ABC. That is, put A is equal to 0 and equate b square terms, equate constant term. Find the value of ABC. So you will get A to be equal to 1, B to be equal to minus 2, C to be equal to 0. Right? I'm not going to do this it's a very easy elementary. So we have watched all the previous videos. So if you put if you put B to be equal to 0, we will have you will get a to be equal to 1, right? So if b is 0, this term will be 0, this term is 0 into something, full term will be 0, so we will have a is equal to 1 if b is 0. So you can easily find the value of a. Now if you equate b square term, right? If you equate b square term, here you will have minus 1, here you will have a, here you will have c. So that means 1 is here you will have minus 1, right? If you equate v square term, here you will have minus 1, here you will have a, equating the coefficient of v square minus 1, here it is a and plus c, right? Plus c, and we know a is 1, right? A is 1. Equate v square term, we will have bb plus c 1. Okay, here we will have ab square, a plus c, and here we will have minus 1, and we know a is 1, so 1 plus c, you will get bb cube. I think I made some mistake. eb plus c 1 plus b square, right? A by b plus bb plus c. Just a minute. Here we have 1 minus b square, right? 1 minus b square is equal to a into 1 plus b square bb plus c into. Okay, sorry. This is not b square, it is b. right? I'm multiplying throughout by v into 1 plus v square. So this bv will get cancelled, so we'll have 1 plus v square. This will be v only, right? Now if I equate v square term, that is if I equate the coefficient of v square, we will have minus 1 here. Here you will have a, here you will have b. So it will be a plus b. So you will have b to be equal to minus 2, right? So you get b to be minus 2. And if you equate constant term, you will get c to be equal to 0, right? So therefore this will become the integration of a by v plus bv plus c. bv plus c divided by 1 plus v square dv is equal to log x plus log c1, right? So very simple. I'm just doing partial fraction here, right? Don't think I'm doing something big. So this is a by v plus bv plus c by v square. Now if you put b to be equal to 0, if you put b to be equal to 0, you will get a to be equal to 1. If we equate the coefficient of b square, you will get b to be equal to minus 2. If we equate the constant term, you will get c to be equal to 0. So c is 0. So this is same as integration of 1 by v dv plus integration of b into v. So it is minus 2v divided by 1 plus v square dv. C is 0. So is equal to log x plus log c1. This is log v. Let us take this minus outside. This is log of 1 plus v square, right? Log of 1 plus v square. F of x, f dash of x. So integration of f dash of x by f of x is log f of x. So take this minus outside. So if we differentiate 1 plus v square, we will have 2v. That is in the numerator. Is equal to log x plus log c1. And this is same as log a minus log b. Log a by b and log a plus log b. So log x c1. So that means b by 1 plus b square is equal to x c1. Now replace v by, we know y is bx, right? Y is bx. So replace b to be y by x. Replace b to be y by x. So y by x divided by 1 plus y square by x square is equal to x c1 is the required solution. That is, this is the required orthogonal trajectory that cuts every member in the family at right angles. Right? We'll move on to the next problem. Very simple, right? So we have to find the orthogonal trajectory for x square plus y square is equal to 2ax. Okay. We'll move on to the third problem. So find the orthogonal trajectory for what next problem? Y is equal to x plus c e power minus x, where c is a parameter here, right? Where c is a parameter. Clear, right? Okay. So here c is a parameter. So we'll do, suppose we have y is equal to x plus c into e power minus x. Call this as equation number 1. So differentiate with respect to x, and then we need to eliminate the parameter. So we will have dy by dx is equal to 1 plus c e power minus x into minus 1, right? And differentiating with respect to x. So we will have dy by dx is equal to 1 minus c e power minus x. All this as 2. Now we need to eliminate the parameter. So we can easily, I'm going to replace the c e power minus x as y minus x. I can replace the c e power minus x as y minus x. Right? This is from 1. So we need to eliminate the parameter c, right? So here there is no c now. Okay. So we will have dy by dx is equal to 1 minus y plus x. Now we need to replace dy by dx by minus dx by dy. So replace dy by dx by minus dx by dy. So this will be minus dx by dy is equal to, see why we are doing this, because actually it's a very easy theory only. So why we are doing this, because we know if two curves cut orthogonal means their slope of first curve into slope of second curve at some point is always equal to minus 1. So when two cuts right angle, right, the slope of m1 is the slope of the tangent line at that point on the curve for the first curve. M2 is the slope of, for example, you can see if I have two curves, right? If I have two curves, right? This is the first curve, and this is the second curve, right? Now you can see we need to find the, suppose for example we need to find the angle between the two curve at this point. Now for this curve, the tangent line is this, right? Now for this curve, right? Now for this curve, the tangent line is this, right? Clear, right? So for this curve, the tangent line is this, and for this curve, the tangent line is this. So this angle between the tangent line, right? So this angle is called the angle between the two curve. Now, since we know that to find orthogonal trajectory, it has to cut at right angles. So that means, suppose if you want to find the orthogonal trajectory means, suppose if these two cut at right angle means, if we know that if two lines cut at right angles, the product of their slope is always minus 1. This is a 10th standard level problem. So the slope of the curve at this point and the slope of the curve at that point are equal to minus 1. That means the slope of the first curve is minus 1 by m2, right? So what is the slope of first curve? It is dy by dx. So minus 1 by slope of second curve. So this is same as minus dx by dy. That is why only we are replacing dy by dx by minus dx by dy. Because for orthogonal trajectory, the curve has to cut at right angles. So therefore, we know that if two curves cut at right angles, the product of the slope is minus 1. So the dy by dx is same as minus 1 by m2. So for that only we are replacing dy by dx by minus dx by dy, because we know the condition that they cut at right angles, right? Okay, I'm just telling the theory part. Okay, okay. I think we have gone out of the context. Okay, so after replacing dy by dx by minus dx by dy, we will have 1 minus y plus x, right? So if you multiply throughout by minus, we will have dx by dy is equal to minus 1 plus y minus x, right? So we have dx by dy plus x is equal to y minus 1. See, it is a linear differential equation, right? It is a linear differential equation in x. So we know that, right? So we know that this is a linear differential equation, right? What is the general format? So dy by dx plus py. So p of x into y is equal to q of x. This is called linear differential equation. The solution is y into integrating factor is equal to integration of q into integrating factor dx, where integrating factor is e power integration of p dx. This we have already done. But here this is ulta, right? It is reversed. Instead of dx by dy, we have dy by dx. So you compare with dx by dy, right? Dx by dy, some function of y into x, some function of y. That's it. So you just replace x by y. That's it. So you will. This is a linear differential equation in x. So therefore, the solution is, first you find the integrating factor. So integrating factor. So that means here p is 1 here and q is y minus 1, right? Compare here. So p is 1 and q is y minus 1, right? Um, so what is your integrating factor? e power integration of p dy, right? Not dx, it is p dy. If it is dy by dx means p dx, but here we are replacing everything by x by y by x. So you will have e power integration of p dy, right? E power integration of p dy is your integrating factor. So p is 1. So e power y is your integrating factor. The solution is x into integrating factor. Usually we will have y into integrating factor, q into integrating factor dy, right? Because it is a linear differential equation in x, not in y. If it is in y means you will have this, but here it is in x, dx by dy. So you replace everything x by y. Okay. So x into integrating factor is e power y. What is q? Q is y minus 1. Y minus 1 integrating factor dy. So x e power y is equal to, so it is u dv, right? I late I l, okay, you have to use formula uv minus integration of v du. So u is y minus 1 dv, it is v dv. V dv is e power y, right? Sorry, dv is e power y dy. Integration of u dv. So therefore, what du is same as dy with respect to y. So du by dy is equal to 1. Here v is e power y only, right? Integrate this. So v is e power y. So this will be u into v. So u is y minus 1 e power e minus integration of v dy. So y minus 1 e power y minus e power y x e power y. So x e power y minus 1 e power y. Let us add some constant c, right? So this is the required orthogonal trajectory. Right? It's a very easy problem. Uh, for finding orthogonal trajectory, first you differentiate with respect to x, and we need to eliminate the parameter. After eliminating the parameter, you replace dy by dx by minus dx by dy. Solve the differential equation to get the orthogonal trajectory. Right? Now move on to fourth problem. Find the orthogonal trajectory of. So very next two problems are very important problem. Find the orthogonal trajectory of. Next two problems are alike problems, right? Find the orthogonal trajectory of x square plus y square, x square plus y square plus 2gx plus c is equal to 0, where g is a parameter here. See, what is this? What is this? This is a family of circles with the center on x-axis, right? So this is the equation of circle in general form: x square plus y square plus 2gx plus 2fy plus c. But f is missing here. F is 0. So center is minus g comma minus f. So we will have minus g comma 0 is the center for this circle. Here g is parameter. So if I keeps on changing g, so you will have all circles that are centered at x-axis, right? Because center is minus g comma 0. So minus g comma 0, g is varying, right? So if a g is positive means we will have circles centered on positive x-axis. If g is negative means you will have those. So this is the family of curves they are given, you need to find a orthogonal trajectory. That means you need to find a curve that cuts every member in the family as well as it has to cut at right angles also. Right? Okay. So we will do this very important problem. The next two problems, that is fourth problem and fifth problem, are very similar problem. So we will do this, right? Very important. So first we have x square plus y square plus 2gx plus c is equal to 0, right? Call this as equation number 1. Differentiate with respect to x. Differentiate with respect to x. So we have 2x plus 2y dy by dx plus 2g is equal to 0, right? Derivative of x is 1, derivative of c is 0, c is constant here. So we have 2x plus 2y dy by dx is equal to minus 2g. Now we will eliminate g, right? So from here we can find the value of minus 2g, right? So what is from here we have 2gx is equal to minus c minus x square minus y square. So that means your 2g is minus c minus x square minus y square by x. But here we have minus 2g. So that means this is same as 2x plus 2y dy by dx. So minus 2g multiply throughout by minus. So we will have c plus x square plus y square by x. So we are done with first step, right? We have differentiated with respect to x and then we have eliminated the parameter, right? Okay. So here you have minus 2g, right? So compare this here. Okay. C plus x square plus y square by x. Okay. Now we will simplify this, right? We will simplify this and then we will replace dy by dx by minus dx by dy. So we have 2y dy by dx is equal to c plus x square plus y square by x minus 2x, right? Minus 2x. So c plus x square plus y square minus 2x square divided by x, right? C plus x square plus y square minus 2x square by x. So this is same as c plus y square minus x square by x. X square minus 2x square is minus x square, right? So if I cross multiply this, we will have okay, we have 2y dy by dx is equal to 2y dy by dx equal to c plus y square minus x square, c plus y square minus x square divided by x, right? This is what we have here. As of now, I have done very simple things, right? I have differentiated with respect to x, no doubt, right? Okay, I have differentiated with respect to x, and then we have eliminated the parameter g. Now we are simplifying dy by dx. So we have dy by dx is equal to c plus y square minus x square divided by 2xy. Now we will replace dy by dx by minus dx by dy, right? Replace dy by dx by minus dx by dy. So this will be minus dx by dy is equal to c plus y square minus x square by 2xy, right? So let us take this minus outside here and then we will cancel this. So x square minus y square minus c, right? X square plus y square minus c. Okay, I'm just taking minus outside here and cancelling this minus minus. This will become plus, these two will become minus. We will have 2xy. So we have 2xy dx by dy is equal to x square minus y square minus c. So we have 2xy dx by dy minus x square is equal to y square minus c, right? So if I divide by y, If I divide by y, we have 2x dx by dy, 2x dy by dy minus x square by y is equal to minus y square minus c by y, right? I'm dividing throughout by y. I'm dividing throughout by y. So we have 2x dx by dy minus 1 by y x square is equal to, so if I divide y separately, we will have minus y minus c by y, right? Now you can see this also a linear differential equation. If I put b is equal to x square, so differently with respect to y, so we have dv by dy is equal to 2x dx by dy, right? So if I differentiate with respect to y, so after the substitution, we will have very one problem. I can replace 2x dx by dy by dv by dy, right? This is 1 by y, instead of x square, I can replace by v, which is a linear differential equation, right? So instead of dx by dy, here we have dv by dy, right? So it is of the form. So just compare, right? So dv by dy, some function of y into v is equal to some function of y. It's a linear differential equation, right? See, it is a general format. This is a general format. Dy by dx. This is a general format, right? So now with this general format, you compare here. So instead of y, we have v, right? Instead of y, we have v. That's it, right? Yes. And instead of x, here we have y. So there you have to replace y by v, x by v, y. That's it. Okay. So therefore the solution is v into integrating factor. So instead of y, we have v into integrating factor. Integration of q into integrating factor dy. This is our solution. So what is our integrating factor? So integrating factor is e power integration of p dy, right? So e power integration of, all are very simple. You just have to understand linear differential equations, right? Okay. We have already done many problems based on that. Um, so minus 1 by y is our p. Minus 1 by y dy. So e power minus log y, e power log y power minus 1. So 1 by y is our integrating factor, right? Solution is v into integrating factor, integration of q into integrating factor dy. What is integrating factor? 1 by y integration of q. So q is our RHS part, minus y minus c by y. Minus y minus c by y. Integrating factor is 1 by y dy. Let us add some constant c1, right? So v by y is equal to, so if I multiply y inside, y will get cancelled, we will have minus dy, and this will be c integration of y power minus 2 dy plus c1, right? Multiply 1 by y will get cancelled, so we will have minus dy. This will be minus c by y square. So y square, if you take that to numerator, we will have y power minus 2. Okay. So v by y is equal to minus y minus c y power minus 2 plus 1 by minus 2 plus 1 plus some constant c1. So you will have v by y is equal to minus y plus c by y, right? Minus minus will become plus c by y plus some constant c1. Now you have to replace this v. So we know y is vx. Sorry. What is v? V is x square, right? So replace v is equal to x square. So we have x square by y is equal to minus y plus c by y plus c1. If we cross multiply this, we will have x square minus y square. Uh, we're cross multiplying by y, right? That is I'm taking LCM by y. So by y plus c plus c1 y, right? I'm just taking LCM here. So y square, y c1, c, y will get cancelled. So x square plus y square minus c1y minus c is equal to 0. This is a required orthogonal trajectory. Is it clear? The required orthogonal trajectory. Right. The next problem is very similar problem. So you just have to understand solution for this. It is x square plus y square minus c1y minus c is equal to 0. This is the required orthogonal trajectory, right? We'll move on to fifth problem. To find the orthogonal trajectory, no doubt, right? Okay. Find the orthogonal trajectory of, this is the last problem I'm going to solve today. X square plus y square plus 2fy plus 1 is equal to 0, where f is a parameter. So this is all those circles that are centered on y-axis, right? So you can see our center is minus g comma minus f, g is 0 here. So these are circles that are centered on y-axis, right? So we need to find the orthogonal trajectory for this family of circles, right? Okay. So you can see there are some similarities, right? Here we have 2gx plus c. Here c value is minus 1. Instead of 2gx, we have 2fy. Okay. The solution is going to be very similar, but it is very interesting problem. Okay. Solution. So we have x square plus y square 2fy plus 1 is equal to 0, right? Call this as equation number 1. Differentiate with respect to x. So you will have 2x 2y dy by dx 2f dy by dx is equal to 0, right? We need to eliminate parameter f now. So we have 2x plus 2y dy by dx is equal to minus 2f dy by dx. So we will find the value of minus 2f from here. We will find the value of minus 2f. So we have 2fy is equal to minus 1 minus x square minus y square. So your 2f is minus 1 minus x square minus y square by y. So here we have minus 2f. So here we have minus 2f. So I can write this as 1 plus x square plus y square, right? Multiply throughout by minus 1 plus x square plus y square divided by y dy by dx, right? Okay. So we have 2x plus 2y dy by dx. Let us take this term here. So 1 plus x square plus y square by y dy by dx is equal to 0. So 2x, so if I take dy by dx common here, so 2y minus 1 plus x square plus y square by y is equal to 0. Right? So we will simplify this. After that we will replace dy by dx by minus dx by dy. So we have 2x plus dy by dx. So it is 2y square minus 1 minus x square minus y square divided by y is equal to 0, right? Multiplying minus throughout here. So we have 2x plus 2y square minus y square is y square. So y square minus x square, y square minus x square minus 1 divided by y dy by dx is equal to 0. So dy, let us take this term to that side, minus 2x. So we have dy by dx to be equal to minus 2xy divided by y square minus x square minus 1, right? So we are done with first step. The first step is we need to differentiate with respect to x, and then we need to eliminate the parameter, and then we have simplified this. Now replace dy by dx by minus dx by dy. So we will have minus dx by dy minus 2xy divided by y square minus x square minus 1, right? So this minus minus will get cancelled. So your dy by dx is y square minus x square minus 1 divided by 2xy. So this will be 2xy dy by dx is equal to y square minus x square minus 1. So 2xy dy by dx minus y square is equal to minus x square minus 1, right? Again, it's a linear differential equation in y. So in the last example, we have found a linear differential equation in x. That is dx by dy function of x, function of y into x, some function of y is equal to some function of y. Here you need to find differential equation in y, right? Okay. So again, if you put v to be equal to y square, differentiate with respect to y. We will have dv by dy is equal to, okay, before that what we will do is we will divide throughout by x. We will divide throughout by x. So we will have 2y dy by dx minus 1 by x y square. We divide throughout by x. Right now you put v to be equal to y square. So dv by dy 2y dy by, okay, dv by, put v to be equal to y square 2y dy by dx. Yes. No. Here differentiate with respect to x. Sorry. dv by dx. Right. Now you have to replace this term. So instead of 2y dy by dx, I can replace by dy by dx minus 1 by x v square is equal to minus x square minus 1 by x, which is a linear differential equation. Solution is Solution is v into integrating factor, integration of q into integrating factor dx plus some constant c1, right? Here we have x only, so it will be dx only here. Okay, now we will find integrating factor. So integrating factor is e power integration of p dx. So e power integration of what is p? P is minus 1 by x, right? P is minus 1 by x minus 1 by x dx. So e power minus log x. So e power log x power minus 1. So 1 by x is our integrating factor. Therefore, the solution is v into integrating factor, integration of q into integrating factor dx plus some constant c1, right? Plus some constant c1. Okay. Now, v into integrating factor is 1 by x, integration of q. Q is minus x minus 1 by x, right? Minus, if I divide individually by x, minus x minus 1 by x, integrating factor is 1 by x plus some constant c1. So this is v by x. If I multiply this inside, we will have minus dx minus x power minus 2 dx. You can see some, it is same as previous, right? So instead of y, we have x here. So we have v by x is equal to minus x power minus 1 by minus 1 plus some constant c1. So we have v by x is equal to minus minus x plus 1 by x plus c1. So v by x is equal to minus x square plus 1 plus c1x by x, right? I'm taking LCM x here. We know v is x square, right? V is x square. Sorry, v is y square. V is y square minus x square plus 1 plus c1x. So x square plus y square minus c1x minus 1 is equal to 0. The required orthogonal trajectory. Right, so you can see there are some similar. Here we have x square plus y square minus c1y. Here we have minus c1x, right? Here we have minus c1x. Here we have minus 1. Here we have minus c. But here c is c here. But the question is here it is c is 1 here. That is why we have 1 here. Right? In the previous problem we have minus c, but in this question instead of c we have 1 here. That is why only we have 1 here. The only difference is here we have, in the previous problem we have minus c1y, but here we have minus c1x. The previous problem we have minus c here, but here c is 1 in the question. So therefore it is 1 there. See, you have to find the similarities between these two when you are doing the problem, right? Okay. I'll give you one more problem, but you have to do. Um, we'll move on to sixth problem, but just I'll give you the hint. You have to solve the problem, right? Find the orthogonal trajectory of y square minus x square, y square minus x square plus 4xy minus 2cx is equal to 0, right? So I'm not going to do the entire problem. I'm just going to give you some hint. You have to do the problem, right? Okay. So we have y square minus x square plus 4xy plus 4xy minus 2cx is equal to 0, right? Okay, so differentiate with respect to x. So we have 2y dy by dx minus 2x plus 4x dy by dx plus 4y, right? I'm applying product rule here. So 4x derivative of y is dy by dx, 4y derivative of x is 1 minus 2c is equal to 0, right? Um, so we have, so if I take dy by dx outside, here we have 2y plus 2y plus 4x minus 2x plus 4y is equal to 2c. Now we will find the value of 2c. So we can find the value of 2c from here, right? So what is the value of 2c? So 2cx is y square minus x square plus 4xy. So that means your 2c will be, so your 2c will be y square minus x square plus 4xy divided by x, right? So from this you get the value of 2c, right? From this you get the value of 2c. Okay. So we have dy by dx 2y plus 4x. I'll take these two terms to that side. So y square minus x square plus 4xy by x plus 2x minus 4y, right? Okay, now cross multiply this. So we will have y square minus x square plus 4xy plus 2x square minus 4xy divided by x. These two will get cancelled. So this term will be equal to y square 2x square plus x square is 3 plus x square divided by x, right? So here we have dy by dx 2y plus 4x. So take this term to this side. So we have dy by dx is equal to x square plus y square divided by 2y x into 2y plus 4x, x into 2y plus 4x, right? Now you have to replace dy by dx by minus dx by dy. Replace dy by dx by minus dx by dy. So this will be minus dx by dy x square plus y square x into 2y plus 4x. This is same as dy by dx is equal to minus x into 2y plus 4x divided by x square plus y square, which is a homogeneous differential equation, right? Which is a homogeneous differential equation. You can see it is also both are homogeneous of degree 2, right? Put x is equal to t that is f of tx comma ty is equal to t square f of x comma y. So both are homogeneous of degree 2. So put y is equal to vx. So we have dy by dx is equal to v plus x into dv by dx. So replace here, you'll get the solution, right? You'll get the solution minus 2 x y plus 2. Yes, I think I'll do from now on, right? So dy by dx is v plus x into dv by dx minus x into 2 y is vx. right? So x square will get cancelled. So b plus x dv by dx is equal to, if I take this minus 2 outside, if I take 2 outside, we will have b plus 2, right? Divided by 1 plus b square. From now on, it is very simple, right? You just have to take this b to that side, right? Minus b, multiply that, and separate dv and dx, integrate, you will get the answer, right? So the answer will be, solution is, take this b to that side, right? Very simple, I do not do, right? Take this b to that side, so this will be minus b, multiply this throughout, so separate dv and dx, right? You will get the answer. Solution is x plus y. That is, after that you have to replace b by y by x. Y square minus xy plus 4x square equal to c, right? You take this as exercise, right? Very simple. Take this b to that side, separate the variables dv and dx one side. You'll be getting log formula, log of something. After that, you replace b by y by x. You'll get the required answer, right? Okay. So we'll stop here. We have solved 6 problems in this class, right? We have introduced what is meant by orthogonal trajectory. So what is trajectory means, if we have a family of circles, and if a curve intersect cuts all the families of curves, then that curve is called trajectory. Suppose if that curve cuts every family of circles or curves at right angles, then it is called orthogonal trajectory. After that, we have solved 6 problems based on orthogonal trajectory. In the next problem, we will be solving some more problems, and then we will be solving how to find the orthogonal trajectory in polar coordinates.